Hello everyone. Today I will be doing the third project in the Arduino Starter Kit, which is titled Levometer. So basically we are going to use the temperature sensor to determine, and then depending on like how hot it is, LEDs will light up. So let's get started with that. Here's the circuit diagram. So just like in project 2, we're going to have 3 LEDs connected to the board. Except this time, instead of using a switch used to be here, instead of using a switch to determine the behaviors, we'll be using a temperature sensor. So as of now, the LEDs are set up good. The LEDs are set up good. So, a reminder of how to set up the LEDs. You have it connected to power, and then we have it connected to ground with the resistor to the cathode side, and then the anode side, the longer end, is connected to the digital pins on the board. So let's get this temperature sensor slotted in. So you're looking for this guy. It has 3 pins. A little hard to see, but on the back, on the flat end, very small writing, it says TMP. That's how we know we're using the temperature sensor. So let's put that in. Yes, Pog, hi Ren. And then the middle pin is connected to the board. I can take. This time we're gonna connect analog, digital. There. 0 pin. Need to connect it to ground, and then should be good to go into the coding part, where more of the fun begins. 3rd pin. So with that set up, making sure it's good. Yeah, we should be good to go. So these LEDs are connected to the digital pins, so that supplies it to power, depending on the coding, and connect ground through the resistor. This temperature sensor is connected to power from the board, this wire. Then this middle pin is going to determine its intake information, the analog pin on the board, and then, yeah, for sure, thanks. Thanks, Coach Tex99. And yeah, so this last pin is connected to ground. It's, completes the circuit. So let's move on to the coding part. So to begin, coding part. Yes, coding part. We are going to define some variables here outside of our setup. And we are using constant, make sure that that never changes. So we declare this variable, but it doesn't change the whole time. So we'll say sensor pin equals A0. Now that's the temperature sensor. So we're saying that the temperature sensor is going to be coming from that pin. And then we are just setting up another constant. So this time it's a float variable, which means that we can have like a decimal point to it. So this is just baseline temp equals 20.0. Whereas an integer is just a solid integer. You can't have a decimal point afterwards. So now that that's done, let's move on to the setup. So we have this function serial.begin, and then 9600, I believe. So this is just to open up a serial port, and it's just 9600 is the speed which the Arduino will use. This is the Arduino coding, so it's very similar to like C and C++, but I believe it's a little different. Because you mostly use the functions that the Arduino comes with, the IDE comes with. But it follows the same behaviors as like C, as in like if statements and stuff like that. Yeah, so now we will declare our pins as well, or set up our pins. So we're gonna do a for loop here. So the way that the for loop works is you put in 3. Oh, thanks for the follow, Coach Tex 99. You put in 3 different arguments. So in our case, we're gonna put pin number equals 2. So we're gonna start at pin number 2, and then the second argument is how far you want to go. So we'll say pin number less than 5. So that means we'll go through 2, 3, and 4. And then each time we finish one of them, we will increment pin number by doing pin number plus plus. So this loop will go from pin 2 and then all the way to pin 5, one by one, or it'll stop at pin 4 after doing pin 4. Now that we've done that and started our for loop, go and say pin mode. So we're using this to declare our pin modes without having to write like 3 different lines for each pin, LED. So we are going to say pin number because right, we're declaring our pin mode. Yeah, so serial begin is just a built-in function that tells like the Arduino to start communicating with all the circuit elements and the computer. So it's just like a declaration function. And then the 9600 is the speed at which it's going to communicate with the computer. So then since these are LEDs, they're going to be outputs. And right, we are going to digital write to these to initially be off or low. So do that, low. And then that's it for our for loop. So now each LED will be initialized and set up. So then we can do stuff with it in the loop functions. So let's do that. So we'll start by saying, declaring an interval, integer, sensor val, and this is going to be equal to analog read. So it's reading from the analog pin as opposed to the digital pin, and then we are going to say sensor pin because that's what we declared it to be at the top with this constant int. So cool. Next, we're going to use the function serial print, which is basically going to print a message to the serial monitor, which is up here, and it'll pop out a pop-up menu and it'll read you information depending on what you're telling it to print, which is cool. So sensor value, and then we will do another serial print, and then this time we are going to just print the value, the integer held by the whatever the pin is reading. So we've got that. And next we will... Right, so this is going to tell us like some number, and we just need to do a conversion so it's something that is closer to temperature. So to do that, we will first convert to voltage. So float for decimal points, then voltage equals sensor val divided by 24 times 5. Okay, 5.0, and then that's right. When you're doing multiplication and division with floats, it's good to add the 0.0 even if you're flat number. So that's that. So that's just a conversion. And then next we will serial print voltage value. This. Like so. So now we are printing the voltage. Good. Right, and now we are going to convert into temperature in Celsius. So and so we add commons. So the way the serial print works is it doesn't print a new line until you tell it to print a new line. So it's just gonna paginate each other going to the end. So yeah. Now let's just throw in our conversion. So it looks like we're gonna say, so we declare a new float, temp equals. Okay, so it looks like the equation is voltage minus 0.5 all multiplied by 100. And lastly, as I mentioned before, we're going to print a new line at the end of this. So we need to use serial print ln, just their way of doing the new line in the serial monitor, and then temp. So we're going to print the temperature, and then we're going to do a new line. So now that we've done that, what we now can do is we can set up our behavior of the LEDs. So let's do that. So we'll do an if statement. So if the temperature is less than our baseline temp, which is just however we're gonna, like, we can declare, we can change this baseline temp to I guess what's the word, to adjust to like the room temperature so that it actually like functions the way we want it to. But for now we can just do this baseline temp plus 2, and then in our if statement what we will do is we will digital write that all of them are off. So this is saying if our temperature from the sensor is below this temperature, then everything's off. So let's do that. Okay, that's done. And then we are going to throw in an else if. So this is saying if it's not in the first if, then it checks if it's in this second if. So if temp is greater than or equal to baseline temp plus 2. So if it's right, so we're doing the lowest case, and now we're doing like a little bit higher case. Put that in here. And this time we're going to say one of the LEDs turns on. So you can just copy this, change this to high. Cool. Then we rinse and repeat. Throw in another else if. Alright, okay, I forgot a condition. So we also need to check that it's not greater than the next case. So 2 ands is it needs to fit both the conditions, not just one of them. So we're saying temp is less than baseline temp plus 4. That's our second condition. Okay. So now let's copy this down. We're doing this again. But in this case it's 4. And this one is 6. So now 2 of the LEDs will turn on. Cool. And then this last one, we're saying if it is greater than 6, then all of the LEDs will turn on. So we don't need that. And this is high. And this is also high. So each time it runs, it will read in something in here, some temperature, through the serial monitor, and then we will that just turned off. We will check and see what the value is, and then depending on that, some of the LEDs will turn on or none of the LEDs will turn on. And lastly, we will add a delay so that it doesn't just keep overwriting over and over again. So having a slight delay, even if it's really, really small, helps run these loops. So that's it for the code. Sort of. So let's plug this in and see what happens. Let's upload this project. Expecting explosion. Oh, forgot some semicolons. Classic. Yep, forgot some semicolons. Gotta be careful with the semicolons. Apparently I wasn't careful enough. Yeah, hopefully it doesn't blow up. It would be a little bad if it blew up. Okay. It finished uploading, so what we should look at now is the serial monitor. If I can get that to show up on the screen, that would be cool. Like that. So the serial monitor keeps telling us the information from the sensor. So it's saying right now the temperature is like 25. So we do this. It increases, and then some of the lights turn on. So it looks like we need to do some calibration here. So let's see. We let it go back to like resting temperature. We can adjust the variables in the code so that it all of the lights can light up. It looks like we're running at like about 26. So let's see. If temperature is greater than baseline temp plus 2, and so baseline temp's 20, but we're at 26, so let's try and increase this to 24. Okay, so increasing that to 24 means that... Okay, so actually baseline temp looks like it's 24. Okay, so maybe 23. What we're trying to do is get it into that sweet spot where everything's off initially at room temp, and then as we heat it up, then all the lights can turn on. So if we're at 23, so it needs to get to 25 for the first one, 27 for the second one. Yeah, this is a temperature sensor. Yeah, so it's just reading in depending on the heat, and then we'll see if this lights up. Okay, so we get it to about 30. So it can't really get to that. Let's see. On temp plus 6. It should be turning on. Greater than 29. Maybe some. I see. So the problem is you're not using the pins here. So it's set up to use pins 2 through 4, but I'm using 3 through 5. Just like that. Switch these around. Guess it's a good lesson that you're paying attention to when you're actually using debugging stuff that's actually working. Plug this in again. And if this is working, like it's serial monitor is not showing anything, but it is lighting up more of the LEDs as we increase the temperature, which is good. If I restart this, okay, there, it's working again. But it looks like at 26 for its resting temperature. Maybe that'll go down, maybe that won't go down. Well, anyways, you can just change this accordingly. And get it, all of them turn on, and we can. Yeah, it's just a little thing where, depending on the temperature, more and more LEDs will turn on. Which is cool. I guess the most difficult part is figuring out the baseline, what the baseline temp should be, depending on like the temperature of the room itself. But that just takes a little bit of adjusting. So that's it for Project 3. Thank you for watching the third part of my Arduino Starter Kit adventures. It was really fun working on it on my stream and talking with all the viewers. So yeah, definitely check out the stream for the next project that I'm going to do, which will hopefully come on Thursday. And I actually worked on 2 projects today, so Project 4 will probably be uploaded sometime later this week, and then I'm gonna do Project 5 on Thursday on my stream. So I'll post the link to that below, and please check that out. So anyways, thanks for watching, and I'll see you in the next video.